Look at the IB paper that we were carrying on with, and this is question 5, and it's all about orphaned orangutans, and we're using a box and whisker diagram in order to find out sort of information about them. So the median weight of the orangutans is this line here in the box, so it's that one, so it's 1.65 kilograms. And then the lower quartile is 1.5 kilograms. And then, the interquartile range is between 1.5 and 1.75, which means it's 0.25 kilograms. And now, the weights of these orangutans are normally distributed, so show that the data does not contain any outliers. Well, what we do is we take the interquartile range, which is this, so 0.25, and we times that by 1.5, and that gives us 0.375. And then we look and see whether all the data is within this range. So if we take the lower quartile, which is 1.5, and we take away 0.375, we get 0, so that's 1.5 times minus 0.375 equals, so that's 1.125. So if the data's within that, that means we haven't got an outlier. Yep, it's in there. So now let's look at the upper quartile. So the upper quartile is 1.75, and we'll add on 0.375 to that. So then we get with that one, 1.75 plus 0.375 equals, and that is 2.125. That is there. So actually there are no outliers whatsoever because they all fit within, they are normally distributed and they fit within 1.5 of the interquartile range. Okay, next. Dr. Scott Popp is investigating the population of otters in Scotland, and he found, based on historical data, that the population of otters could be modelled P equals 7,500 plus A times 1.09 to the power T, where A is a constant, T is the number of years since the start of 2000. So T is always going to be greater than 0 because time is never negative. At the start of the year, the population of otters was 8,000. What's the constant A? So we know that 8,000 equals 7,500 plus A times, and now it's 1.09 to the power 0. So that's the equivalent of 1. So that means 500 equals A. So A equals 500, sorry. Find the population of otters in Scotland at the start of 2020. So in that case, we've got 8,007, so P equals 7,500 plus 500 times 1.09 to the power 20, since that's 20 years later. So now you do 1.09 to the power 20 times 500 equals, and add that on to plus 7,500. So that would be, we can't really have a point where it's not right, so that would be 10,302, because so rounding down to the nearest otter, 302 otters in the year 2020. I hope so. And Scott Pop estimates the peak population of otters that Scotland can sustain is 15,500. So how do we go about finding that? So we know that 7,500 plus 500 to the power 1.09 to the power t equals 15,000. Oh no, 15,500. Really must pay attention. So that means that 1.09 to the power t would equal 15,500 minus 7,500 over 500, which is, isn't that 8,000 over 500? Let's just do, so 8,000 divided by 500 equals 16. So 1.09 to the power t equals 16. So if we take a little log of both sides, so we could just do t equals log of 1.09 to the 16. So let's just get a log up. So that would be log 1.09 to the power 16 equals, so that should be 32, yes? So t equals 32, and that means that in 2032, going to have the most otters. Going to be a great time to visit Scotland. Right, the perimeter of a rectangle P, whose width is double its height, can be represented, so area to perimeter. So if that equals 2 and that equals 4, that means 2, 4, 2, 4, so that means 8. So that means the perimeter of that would be, good lord, I'm not doing a really bad job, 12, and the area of that would be 8. And this is something that's modelling that. I have to say I didn't do a very good job of explaining that at all. Anyway, write down the value of p equals 32. So p equals 32. Write down the value p at 32. So p equals 32. Well, we haven't actually got that, have we? We've got the area equals 32, but anyway, I'm assuming that means 24. The area of PA equals 0 to PA, so the range of the area is up to 32. And then the value is, so that means the value of n is going to be 24. So the range is 32, so then the value of that is the number is going to be n. On the axes, draw the graph of the inverse function. So what you have to do to find an inverse function is pop in x equals y, which is this one there, so you've just got to make sure it goes through all those. So that's that bit. We've done that. Right, and now, then we put in this. So that's the point where that's going to change. That's the point there. It's going to go like that. I know that's not brilliantly done, but that'll do. So that's sort of... So essentially what you're doing is you're reflecting this line through x equals y, and that is how you find the function of p to the minus 1. In the context of the question, explain the meaning that p to the minus 1, 12 equals 8. So that means that if we look at this, p to the minus 1 of 12, oh well that does work, equals 8. So it means when you look at the inverse function on the graph, you'll see that at the point where p equals 12, then, or rather a equals 12, p equals 8. And that is what that means. So where the perimeter is equal to 12, the area is equal to 8. And that's what it means now. That's it, basically. We'll stop there for a minute.